Hi kiddos, and welcome to your first experience with Flipped for AP and IP Chemistry. We're going to be doing a bit of a review in this unit, especially the naming part is a review. Most of what we're going to talk about with oxidation numbers is new, and then I'm going to teach you how to do net ionic reactions. And that's all relatively new information. And then we will actually start predicting reactions towards the end of this unit. So let's go ahead and get started on this unit. Now, to introduce oxidation numbers, I want to review what we covered with ionic compounds in terms of their ionic charge. Because when we get into oxidation numbers, the ionic charge is a key component. So let's review that. Group 1 metals, sodium, potassium, and so forth, lose one electron to be just like the noble gases, and they have a charge of +1. Group 2 metals, calcium, strontium, magnesium, barium, that little cluster, are +2. Group 13 metals are almost all. The ones you're going to come across are going to be +3. So those are some of our firm rules for our cations. And then let's look at our anions. If it is, remember cations are positively charged and anions are negatively charged. It's a refresher if you don't. Nonmetals gain 4 electrons to become -4. The metals in group 14 lose 2 electrons to become +2 or 4 electrons to become +4. Nonmetals in group 15 are -3. All they need are 3 electrons to be like the nearest noble gas. Metals lose either 3 electrons to become +3 or 5 electrons to be +5. Nonmetals in group 16 gain 2 electrons. Nonmetals in group 17 gain 1 electron. And that's to become anions. We're going to see for many of these there are other possibilities, but this is what they're going to do to become ions in ionic compounds. Now, let's look at the oxidation numbers here. Our uncombined, what an oxidation number is, let me backtrack. Oxidation number is a way of tracking electrons. It's an accounting system, per se. We're not saying all the time that this is a charge on the substance. It's an accounting method to try to track electrons as we study bonding and properties. So there's some rules involved in this accounting method. If we have an uncombined element, not in a compound, like iron or oxygen, and remember oxygen's diatomic, then the oxidation number is 0. For binary ionics, it's simply going to equal the charge. So if you notice, those oxidation numbers were simply equal to the ionic charge, which is why I shifted that chart a little bit in your notes so that we could cover those ionic charges again. Remember, group 1's +1, group 2's +2, group 13's +3. Now, there's a little trio, and we'll revisit this again later in the notes, that you also have to memorize our +2, +1, +2, zinc, silver, and cadmium, and I have a method for doing that for you. Fluorine in a compound is -1. If it's pure fluorine gas, it's 0, but in a compound it is always -1. So that's what I call a firm rule, and you're always going to want to assign your firm rules first, and then we can do calculations if needed. Hydrogen is almost always, it's not a firm rule, but it's, you know, a pretty secure rule. It's +1, except when it's with metals. All by itself with a metal, nothing else present, hydrogen would be -1, because it would be the most electronegative. Oxygen is a somewhat secure rule. It's almost always -2, but there are a class of substances called peroxides. This shows sodium peroxide, in which the oxygen is, no, that's actually sodium oxide. This shows sodium peroxide. This is sodium oxide, sodium peroxide, because the oxygen's -1. And then this isn't a class, this is a single example of oxygen difluoride, in which oxygen's +2. Okay? Now, when it's covalent or molecular, what you're going to do is assign the most electronegative element the most electronegative that it can be according to the periodic table. That's its ionic charge. The anion that it would form is its most electronegative. Now, how do you know what's the most electronegative? Well, move towards fluorine. The one that's closest to fluorine without going diagonally is typically the most electronegative. Okay, fluorine's the most, oxygen is next, and then comes chlorine. Now, most formulas, with the exception of ammonia, in which the most electronegative is first, most substances, the most electronegative is this second element present. All right? Now, the last rule is the sum of our oxidation numbers in a neutral compound has to be 0. And the sum of oxidation numbers for an ion has to be equal to its ionic charge. All right, we are going to try some of these in our next video. So until then, this is signing off.